Hey, what's up guys, and welcome in a new video. Don't forget to subscribe to the channel. Thank you for following this one. And after to discover the pod world, we are talking about the replicaset. So this is really important because the replicaset is the component which manage pod. So this is really important. By the way, when you use Kubernetes, you'll see that you never push a pod manually and directly a pod, but you use replicaset or deployment if you want to push some pods on your Kubernetes cluster. So let's go to meet replicasets. So as a reminder, as previously, we compare the pod encapsulation with the Russian dolls. Deployment handle the replicaset through the replicaset controller. Then the pod is managed by this replicaset, and pod communicate with the container runtime to create a process isolated by the namespaces and seg groups that provides us a container orchestration with our Kubernetes cluster. So what is the replicaset, or what is the role about a replicaset? This is like a pod doctor. But first of all, the replicaset is managed by the replicaset controller, of course, and it allows you to manage the number of replicas and ensure it. To do that, this is based on the safe healing and or manual scaling. But it doesn't manage the deployment strategy. It's a role about your deployment, so we'll see it later. And the drawbacks about replicaset is the lack of version, so you can't manage version upgrades or how to upgrade through the replicaset, and the replicaset provides you only manual scaling, not the auto scaling. So this is a role about HPA, so horizontal pod auto scaling. We'll see it later. So now, what is the manifest to create a replica? No specific command exists to create this object, but to help you, and now that you know that the deployment creates a replicaset, and you can use a part of the deployment to create your replicaset. So you can kubectl create a deployment and edit this. We'll discover that in the demo part just after. As usual, in the manifest, the first part is based on metadata, the kind replicaset, the API version group, and the name of our replicaset, in this example, frontend replicaset. In the second part, you can see we have specifications about our replicaset. And in the specifications, you can set the number of replicas. This is really important, of course. This is how many pods do you want. So this is here where you handle your manual scaling. And after that, the core of the replicaset is based on a pod templating. First, the match label selector to associate which pod this replicaset can manage, and the specifications template of the pod, like the pod manifest. This is the same thing like the pod manifest. So when you see a replicaset manifest, you just have in your mind that the replicaset don't create directly pods. This is like a replicaset check which pod it can manage and check the number of it. Of course, you have the classic or usual kubectl CLI for kubectl get replicaset, kubectl edit replicaset, describe or delete replicaset. This is the same things like pod or deployment. So now let's go to the demo part. So like I said, you can't create directly a replicaset with a manifest, or you can't handle it with a kubectl run like to create a pod. So you can just use a workaround or tricks to do it. We can just use kubectl create And like I said, you can create a deployment, so you can use the deployment or deploy argument and specify the name of our deployment, for example, test, and the image which we want to use, for example, Nginx, and we want to use a dry run, so dry run option equal to client, because we don't want to run it on our server, just locally on our kubectl client, and -o YAML to just check that we can generate a YAML about deployment. So I push it into a dedicated file, for example, replicaset.yaml, and now I can edit our replicaset. So in this replicaset, we have, of course, this is not again the replicaset. We just need to change the kind, and for example here replicaset. Be careful, you need to add the uppercase on the S character. We have the API, the same API version between the replicaset and the deployment, so this is okay. We have the metadata. We can just remove the timestamp creation, the label app test, cool, and the name of our replicaset. We can keep test. We have the number of replicas, so this is 1. Yes, no, we want to change it. We push 3, for example, so we want to have 3 nodes, and 3 nodes with the same label based on the app test, so key value app. This is the key, and test value label. So to do that, we use in this replicaset the match label selector based on app test, and after that I just remove strategy. This is just this line which is handled by the deployment. So we remove it, of course, because we are in the kind of the kind of this manifest is replicaset. And after that, we have our template to generate some pod. So we keep the metadata, we remove creation timestamp, we keep, of course, the label app test, because this is here where we the replicaset can match the selector here based on the match label app test with some pods with the same label app test. And after that, this is the specification about our pods. So we want 3 pods for our 3 pods, containers with image Nginx, and the name of this container Nginx, resources we can remove it, and status again. I can just push it, so use kubectl apply. We already saw that, and we want to push this replicaset. What we can check? We can check kubectl get replicaset here, kubectl, and we have our replicaset name test. The desired number of replica is 3. The current number of replica is 3, and 3 are ready. And the age is 12 seconds. We can now just check our pod. So we have our pod here. So we have test and the ID of our pod. So we have 3 pods, and each pod is running. So this is cool. What we can do, we can, for example, kubectl edit replicaset. So replicaset, sorry, have an alias, and this alias is just rs, and you can just, for example, edit replicaset test, and you can change, for example, the number of replica here. We can push to 5, and if I just register, save it, yes, now we have 5 pods here. And this is the same thing if I just want to decrease the number of pods. I can push 3 pods, And now, of course, we have 3 pods. But remember, this is just based on the match label selector. So, for example, what I can show you, I can, for example, kubectl delete our replica set named test. Okay, now we can just check that our replica set is removed. Okay, and of course, if I just kubectl get pod, nothing into it. Okay, and what I want to do, I just want to create with kubectl run. We already saw that. Kubectl run, this is the command to create a pod, and I want to create a pod name, for example, Nginx, with the image named Nginx2, and I want to add a specific label, name, for example, app equal test. So I can run this command, and now if I just check kubectl get pods again, what we have our pod. If you want to check which label do we have, we can run show labels here, and we can see that we have app equal test label. And this is a little bit tricky, but if we check our replica set, remember that we have here our selector based on match labels and the key value app test. So in this case, what Kubernetes can do, Kubernetes check how many pods do we have with the match label app test, and just if we already have a pod with this, this is not 3 replicas that the replica set create, but only 2. So let's go to check that. We can kubectl apply, again apply, and we apply our replica set, apply kubectl -f apply, sorry, and we can just get the replica set here. Of course, we have test 3 and 3 pods ready. This is like in the previous use case. But if we check into kubectl get pods, what we have 3 pods, but not exactly 3 same pods. We have 2 pods generated through the replica set when we create this replica set, but one other pod, this is our previous pod named Nginx. Of course, because the pod already have the labels. If we check the show labels here, of course we have 3 pods with the app equal test label. So this is really, really important to know that and to have these things in your mind. What we can do now, we can, for example, use and create our first manual scaling. And to do that, this is really, really easy. For example, so we can remove all. We can delete the replica set. We can kubectl delete pods Nginx, and now so we can delete pod kubectl. Yes, of course, I remove sorry, kubectl get pod. I remove the replica set, and the replica set match all pods with the app label selector based on the app equal test. And after that, if we remove the replica set, of course, replica set remove all pods which it manages. And after that, what we can do, we can apply again our replica set. So of course we have 4 pods, and in creating status. And if I check our replica set here, we have 3 pods in ready status. And after that, what we want to do, we want to scale. So to do that, we use kubectl scale command. We need to we want to scale a replica set. So I can show you here. You can use this kind of command, kubectl scale replica set. So you can scale some object like replica set, like deployment or stateful set, or stuff based on scaling, of course. You can't scale, for example, we'll see service, you can't scale service. So replica set, we want to scale the replica set, and the name of this replica set is test, and I want to change the number of replicas, and I want to set it, for example, to 10. And now, if I just kubectl get rs, we have, for example, 10 desired pods. The current is 10 desired pods into our replica set, but in reality, in running status, we only have 5 pods. If I run it again, of course, we have 10 pods, and I can check kubectl get pods again. Of course, we have 10 pods here. If you want, you can decrease the replica numbers, and just, for example, to push to 1. If I run again kubectl get pods, I have only 1 pod, and of course, we have the same thing into kubectl get rs. What we can do again, maybe just what we can do, we already saw that, okay. And if you want, you can scale to 0. This is really interesting. For example, you want to cut your demo, for example, or stuff like that. You can set the replica set to 0, and if you run again, of course, kubectl get pod, no pod, but you have your replica set, but the desired state is just to 0. This is very interesting. For example, when you want to restart quickly all pods, and to drop all pods, and to run again many pods, and bypass all stuff all stuff provided by deployment, for example. Deployment can roll out restart, for example, but this is slow sometimes, and sometimes you need to quickly just restart all pods, and to do that you push to 0, and after that you push, for example, to 10, and you have your pod. Of course, with kubectl get pod, you have all your pods are just restarted, dropped, and restart again. So this is really very useful when you need to go quickly to restart all pods. And that's it, I think. Yeah. Another thing, if you want, you can order which pod can be deleted first. So just a last example. For example, you can run here. We can run replica set test to 5. If you do it, kubectl get pods. If you, for example, if you push replica set to 4, like here, you can see we have dropped this pod, so the 87445 ID, but we are not sure that this is this pod before we run the kubectl scale replica to 4. We don't know which pod are deleted. So if you want to be sure which pod are deleted, this is a little tricks, not really useful but interesting to know. To do that, you can run kubectl annotate to add an annotation on a pod. For example, if you push again to 5, now what we have this is my alias kubectl get pod, and now we want to decide that the first pod that we want to drop is, for example, I don't know, GQHFH. So to do what we want to do, we can use kubectl annotate to add an annotation. What we want to annotate, this is a pod, and we want, for example, annotate this pod with a dedicated annotation, so controller kubernetes and kubernetes.io/pod deletion, and we want to set deletion cost, sorry, and we want to set it, for example, to 1, and we want to set another pod here, this one, we want to set it to 2. So for example, here we are just to order we are just to set in which order we want that when we scale down, which pod can be destroyed first and the next. So we have 3 here, for example, for which one, E8 LRK, and after that the 4 is just this one, BLW6K, like that. And now imagine that you want to just set the replicaset to 4, and we can check it again. Here what we have, we just keep all pods with annotation. So this is the first thing, and we drop this pod. And if we push to 3, now we just check that we use the order and keep keep pods with the higher annotation. So for this annotation for the pod deletion cost. You can see here when we go from 4 to 3 here, we just remove the pod with GQHFH. So this is the lowest number for pod deletion cost. And if we push to 2 here, for example, and get pod again, what we delete, of course, the GNQ29, because this is the lowest annotation here. And if we push, of course, to 1, we keep, I'm pretty sure, we keep the BLW6K normally. Yes, because this is the higher annotation for the pod deletion cost. That's it for today. Don't forget and don't hesitate to subscribe to the channel. If you want to support me, you just like and comment this video, and see you in the next one. Bye.